Hello everyone, today I'll show you how to set up your ArgoCD for deploying different services to multi-cluster environment. In previous video I showed how to set up monitoring system using Grafana, Locky, Mimir and Prometheus. So based on these services I will show you how to set up them to multi-cluster environment. So why should you use ArgoCD? I think that it's very useful when you have a lot of environments and a lot of clusters. For example, if you have about 5 or 10 clusters, it is not so necessary to use ArgoCD, but if you have more than 10 clusters for about 20, 50, 100 clusters or thousands, you can't do all this stuff without ArgoCD. We will use application sets and apps of ArgoCD to deploy all this stuff to our clusters. So I will create free clusters. I will show you how to set up your ArgoCD and how to deploy all the services among these clusters.
How does it work? ArgoCD stands on GitOps pattern. It is when the source of truth, it is only your Git repository. So for example, you have a Git repository where all the manifests of your workloads are stored. It is a very good idea because all your manifests can be easily versioned. Also, you can roll back if something happened. So for example, we have a Git repo, we have about 3 Kubernetes clusters, and we have manifest here in our Git repository. How to synchronize this manifest with your Kubernetes clusters? For this purpose, you can use ArgoCD. ArgoCD checks your Git repository for updates and apply these definitions to your Kubernetes clusters or different environments. When you first time connect your Kubernetes clusters to the ArgoCD and push some manifests to your Git repo, ArgoCD will find these manifests and synchronize them with the state in Kubernetes clusters. So for example, our manifest contains something like specification of containers like Nginx with a tag. And this manifest applies to your Kubernetes clusters, and Kubernetes create a workload. So in this case, it will be deployment with the pods, services, and other stuff based on your manifests. And for example, somebody push changes to a Git repo, maybe it will be updated manifest with a different tag of the image for your manifest. So ArgoCD catch this definition and compare the desired state with live state in Kubernetes cluster. When it happens, it's called out of sync because your workload differs from the desired states from Git repository. So for example, we changed tag for our Nginx image. And after that, ArgoCD apply this manifest until the desired state have no differ with the live state. So this state called synced. And our workloads are successfully synchronized with our desired state in Git repository. ArgoCD have different concepts of deploying your services in Kubernetes clusters. First concept, it is application. It is a custom resource definition of Kubernetes. It is defined by 2 key pieces of information. It is a source, where you can define repo URL, target revision, path, and environment, and destination reference to the target cluster and namespace. ArgoCD application, not the guestbook service itself. An application is just an abstraction of ArgoCD that has to look somewhere compared to something and so on. It is not a guestbook service. It is essentially a link, a shortcut, like on the desktop in Windows. At its core, the application is simply an observer told to look at a certain location and compare the current state within the cluster to that location. So in this case, it is Git repo. Another concept, it is apps of apps. You can create an app that creates other apps, which in turn can create other apps. This allows you to declaratively manage a group of apps. This can be very useful when you need to deploy several code-dependent services, when the existence of one without the other is impossible. So you should deploy them as a group and delete them as a group too. So For example, we can create a Git repository with the following structure. Each YAML file in the templates folder reflects an individual ArgoCD application. This is not Helm chart in the classic sense. In this case, using Helm templating, we can conventionally configure the templating of our ArgoCD application. It is very important not to forget that an ArgoCD application is not the service itself, but only a shortcut to it, a reference, an observer. So let's take a look at one of them. If everything is clear with the destination, the service will be deployed in the same cluster as ArgoCD, then the source directive raises some questions. Repo URL is just a link to the repository where the Helm chart resides, which is used to deploy the guestbook service. This is a Helm chart in the classical sense, with templates like deployment, service ingress, and so on. Path is the folder where the source Helm chart itself is located for deploying the service. Let's take a look at the values.yaml of our apps of apps. So here we can see destination like server. It is directive for ArgoCD application and also source. So we can see that we template it here. So it's clear. And let's see what we see when we follow this link in repo URL to the Helm guestbook folder. So as I said before, it is a Helm chart in classic sense. So here we can see in this folder, like templates, there are a lot of templates like deployment service ingress and so on. So default values.yaml, chart.yaml. So this is the just based Helm chart. So in other words, when we create application, we just say to ArgoCD watch for updates to the repository from repo URL, specifically the Helm guestbook folder, and apply anything you unitize to the cluster from the destination directive. So we create other applications using this analogy as well. So it's very similar with Helm guestbook. So it only differs by the name of application and differs by path where to find Helm chart, but repo URL, target revision, server is the same because values.yaml are the same for all these templates. So we just create an application that creates using Helm templating other applications, which in turn spawn objects based on the Helm charts they look at. There is a guestbook application that spawns a Helm guestbook application and a customized guestbook application that spawns deployment service and other resources based on the Helm charts in the Git repository they are looking at. So when we create application, ArgoCD just monitor Git repository, which we defined as the source of the guestbook apps of apps. If there will be any changes, it will apply to the guestbook apps of apps, and then guestbook apps of apps apply all these definitions to the Helm guestbook application and customized guestbook application. But Helm guestbook application monitor another Git repo with a Helm chart, and customized guestbook also monitor another repo with the own Helm chart. So I hope that's simple for you. It's just the observers that monitor definitions between desired state in Git repository and live state in Kubernetes clusters. And these apps of apps monitor definition of these applications. So I think it's clear. So, and after Helm guestbook application and customized guestbook application, just spawn resources and objects in Kubernetes cluster based on their manifests and based on their Git repos that they are monitoring. Finally, we come to the most delicious thing, it's application set. The most common use case for application set is when we need to deploy the same Helm chart to different clusters. So it is also useful when we have a huge number of services, but all of them are based on the same Helm chart. It will allow to template the generation of these services and not to describe a separate application for each service. So when we use application set, it allows us to use different generators to easily produce our applications. So for example, it is a list generator, cluster, Git, metrics, merge request generator, plugin generator. There are a lot of different generators, but this is a main generators that are used by application set. In this example, applications will observe folders in the Git repository, such as engineering dev and engineering prod folders. These folders contain the Kubernetes manifest for deploying a particular service. So as we can see here, we use templating. So we have a list of elements, and after we pass these values to our template, so application set will spawn two applications. These are engineering dev guestbook and engineering prod guestbook, and we'll deploy them to their respective clusters. In essence, application set walks through the given items in the list generator using a loop and supplying the resulting values to the template of application. For example, if you need too many values in the list generator, that's simply writing them in the YAML file application set will be unreadable. You can take these values from another generator, such as Git. In this case, the Git generator retrieves the .yaml file from the specified repository, and the list generator converts this file to JSON and pass values to the application template. So let's see what inside this file. So there is a YAML file with different values. We parse these key components into the JSON as we specified here. And after this, we use these values in our template, like name, chart, repo URL, version, release name, namespace, and all we have here. The result of execution will be an application set, which will spawn two applications, component 1 and component 2, which will follow different Helm repositories that will spawn in different namespace, have different release names, different chart versions. So that's it. So another very useful generator, it is cluster generator. In ArgoCD, managed clusters are stored within secrets in the ArgoCD namespace. The application set controller uses the same secrets to generate parameters to identify and target available clusters. It provides the following parameter values to the application template for each cluster. It is name, name normalized, server, labels, and annotations. In this example, the revision value from the generator's clusters fields is passed into the template as values revision, containing either head or stable. It is based on which generator generated the set of parameters. We can add different labels to our clusters in ArgoCD. So for example, if we have labels like type with the staging value and production value, we can define custom values for each cluster. For example, for staging cluster, revision will be a head, and for production cluster, revision will be stable. So it's just a stable branch in Git repo. So, and after we just create application based on cluster name in ArgoCD and guestbook at the end. So, and we use values from here in the target revision. So it's just simple templating. One of the most powerful generator, it is Git generator. Suppose you have a Git repository with the following directory structure. This repository contains two directories, one for each of the workloads to deploy. For example, it is Argo workflow controller and Prometheus operator. We can deploy both workloads using this example. The result of the execution is an application set that will spawn two applications named Argo workflows and Prometheus operator, the source of which will be the full path to the manifest received from the generators. Note that we don't describe each application separately, it describes themselves based on the folder names using templating. So this way we can create hundreds of folders, and this application set will automatically generate 100 applications. So it is very useful. We just scrape path names from these folders, from this Git repository, and after this we use these values in our templating. So as I said before, in this folder, in this Git repo, we have two different folders. It is Argo workflows and Prometheus operator, and after this we use names of these folders in our application names. We use full path to manifest in these folders as the sources of our applications, and we use name of the folder as the namespace, and also we create synchronized policy to create namespace if namespace doesn't exist. Another powerful generator it is a matrix generator. Matrix generator combines the parameters generated by two child generators by combining both generators' parameters to produce every possible combination. This allows you to gain the properties of both generators. For example, we can use Git generator and clusters generator. Our goal is to deploy both applications onto both clusters, and more generally in the future to automatically deploy new applications in the Git repository and to new clusters defined within ArgoCD as well. First, the Git directory generator will scan the Git repository, discovering directories under the specified path. It discovers the Argo workflows and Prometheus operator applications and produces two corresponding sets of parameters. It is path and path base name. So next, the cluster generator scans the set of clusters defined in ArgoCD, finds the staging and production cluster secrets, and produce two corresponding sets of the parameters. It is name and server of our clusters. Finally, the matrix generator will combine both sets of outputs and produce this. So, as we can see, it is very useful and flexible for our purposes. Let's finally come to our case study. Based on the previous video about observability, we remember that we use Grafana to display dashboards, Mimir to store metrics, Lucky to store logs, and Prometheus to collect metrics and pass them to Mimir, and Promptail to collect logs from paths and pass them to Lucky. So we obtain that Grafana, Lucky, and Mimir have only one central replica, to which many Prometheus and Promptail replicas send data. In turn, Lucky and Mimir are also just a source of data for Grafana. Thus, we conclude that Promptail and Prometheus should be deployed in every Kubernetes cluster. So application set will help us with this. So when adding a new cluster under ArgoCD management, Promptail and Prometheus will be automatically deployed there. And Grafana, Lucky, and Mimir will be deployed using apps of apps, because they are essentially small parts of something bigger, and they depend on each other in our case. So in the second part of this guide, I will show you on practice how to install ArgoCD and prepare your clusters for deploying your applications. We will use apps of apps for deploying Grafana, Lucky, and Mimir in our central cluster, and we will use application set for deploying Promptail and Prometheus along all our clusters. So thank you very much for viewing. I hope that this video will help you to understand ArgoCD concepts